Hello, everyone. Welcome to Brain Blitz Audios. In today's episode of NEET Preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. So until now, we've been dealing with units and measurements. That was the first chapter. Today, we're dealing with the second chapter, that's motion in a straight line. This is the second chapter in the grade 11 syllabus for CBSE. And this chapter is pretty important because it starts the branch of physics known as kinetics. So stay tuned till the end of the video because we'll be discussing some tough questions which can be solved easily. So are you ready? Let's go. Here is our first question. If a car at rest accelerated uniformly to a speed of 144 kilometers per hour in 20 seconds, it covers a distance of 400 meters, 1,440 meters, 2,880 meters, 25 meters. Let's look at how we solve this question. So first things first, let's analyze the question so that we can write down the quantities. The first part of the question says if a car at rest. So at rest implies that the initial velocity u is equal to 0. Accelerated uniformly, so we have an acceleration a, to a speed of 144 kilometers per hour. So our v is equal to 144 kilometers per hour. However, we need to convert this into meters per second because the distance that we need to find out is in meters and the time given is in seconds. So how do you convert kilometers per hour to meters per second? Here's an easy way out. Whenever you want to convert something into meters per second from kilometers per hour, just multiply by 5 by 18. Multiply the quantity by 5 by 18. So you'll get the answer in meters per second. And if you want to do something in meters per second to kilometers per hour, just multiply by 18 by 5. So therefore, that will give you the answer in kilometers per hour. Here we need to convert it to meters per second. So 144 into 5 by 18. So I'm going to divide 144 and 18 by 6. So 6 goes into 18 3 times. And when you do 144 divided by 6, you'll get 2. That's 12. 2 is left. 4 comes down. 6 4s are 24s. 24 minus 24 is 0. So we get 24 6's go into 144. And 3 goes into 24 8 times. So we have 8 times 5. That is 40 meters per second. So V is equal to 40 meters per second. And we have the time given in 20 seconds. So we need to use the 3 equations of motion here in order to find out the distance, that is s. So first we need to find this uniform acceleration a. And you know the first equation of motion. The first equation is v is equal to u plus at. And we can twist this in using acceleration. So we'll get a as v minus u by t. And so we'll put in the values. V is 40 minus u is 0 divided by t is 20. So it's basically 40 by 20. 0, 0 gets canceled. 2 goes into 4 2 times. So you'll get the acceleration as 2 meters per second square. Great. But we're not here to find acceleration. We need to find the distance. And for the distance, we use the second equation of motion. And that is s is equal to ut plus half at squared. Let's put in the values. S stays as it is. U, the initial velocity is 0, t is 20, plus half into a is 2, and t squared will be 20 squared. So 0 into 20 is 0, plus half into 2 is 1, so that's 20 squared left. So our S will be equal to 20 squared. 20 times 20 will give you 400. So the right answer is S is equal to 400 meters. And if you look at our question, we find that option A is the right option. Option A, 400 meters is the right answer. Let's move on to our second question. A ball is dropped from a bridge 122.5 meters high. After the first ball has fallen for 2 seconds, a second ball is thrown straight down after it. What must be the initial velocity of the second ball so that both the balls hit the surface of the water at the same time? So this kind of sounds like complicated, but the first thing we need to do is to simplify it. So what we need to do is we need to find the time taken for the first ball to fall down 122.5 meters. And after we find that, we remove 2 seconds of it because the second ball was thrown 2 seconds after it. And then using the revised time, we find the velocity, initial velocity of the second ball. So for the first ball, the height is given 122.5 meters. And it says a ball is dropped. Whenever a ball is dropped over from something, we consider its initial velocity as 0. And since it's dropped from a bridge, and this is downward motion, that is gravitational motion, the acceleration g will be equal to 10 meters per second squared. Now we need to find the time taken by the ball to reach the ground. And we do that by using the second equation of motion. And that is h is equal to ut plus half gt squared. Now notice I've removed s as h and a is g. So since it's for a case for height, s becomes h and the acceleration becomes the acceleration due to gravity. Let's plug in the values. So h is the height, and the height is 122.5 meters, is equal to u is 0 times t plus half into g is 10 into t squared. So it is half into 10 into t squared. So we have 122.5 meters is equal to 5t squared. Now let's take t squared. T squared will be equal to 122.5 divided by 5. So in order to make our calculation simpler, I'm going to do 1225 divided by 50. So essentially what I did is I multiplied 10 to both sides. So the division of this would be the same as the division of that. So 50 goes into 122 twice. So that's 122. And then it becomes 225. 50 goes into 225 4 times. So that's 200. So we have 25 left. 50 goes into 250 5 times. So we have t squared as 24.5. So we can approximate 24.5 into 25. So t squared is approximately equal to 25. And the square root of 5 would give us t as 5 seconds. Again, it's an approximate value. So this is the time taken by the first ball to reach the ground. Over here, the question states that after the first ball has fallen for 2 seconds, a second ball is thrown straight down at it. So now let's write the quantities for second ball. So for the second ball, there is a definite initial velocity u that we need to find out. H is 122.5 meters. Time, because it's thrown 2 seconds afterward, it'll be 5 minus 2 equals 3 seconds. So now we're ready to find out the initial velocity of the second ball. Once again, we use the second equation of motion. H is equal to ut plus half gt squared. The value of g does not change, so g remains 10 meters per second squared. So now h is 122.5 is equal to u into the time is 3 plus half into 10 into 3 squared. So therefore we have 3u plus 5 into 9. So 122.5 is equal to 3u plus 45. 3u is equal to 122.5 minus 45. So 1225 minus 450, 5, 12 minus 5 is 7, 11 minus 4 is 7. So we have 77.5 as 3u. We can write u as 77.5 divided by 3, which again can be written as 775 divided by 30. This is just multiplying by 10 on both sides. So let's do the division. 775 divided by 30. So 30 goes into 77 twice. 60, that's 17. And we have 175. So 30 times 5 is 150. So we have 25. And then we have a point here. So we get a 0. So 30 goes into 258 times. So that is 240. And then we have 10. So we'll make it to 100. So it becomes 3. So we have u, the final value of u is equal to 25.83 seconds. And so we can approximate u as 26 meters per second. That is the unit of velocity. And so therefore, we can write option A, which is the closest value to 26, as the right option. 26.1 meters per second is the initial velocity of the second ball, so that both the balls hit the surface of water at the same time. So we've got something approximate, and that is good enough with a reasonable amount of estimation. Next question. A particle is thrown vertically upwards. Its velocity at half of the height is 10 meters per second. Then the maximum height attained by it will be, and we have the value of g as 10 meters per second square. So how do we solve this question? So we'll consider the maximum height as capital H. And so over here, at half of maximum height, no, this is at maximum height. We use now the third equation of motion. V square is equal to u square plus u square minus 2gs. The reason why minus came here is because our motion is upward while the direction of g always remains downward. So therefore, v square will be equal to u square minus 2gs. And the final velocity at half of the height is given as 10 square. U is 0, so 0 square minus 2g into half of maximum height. Since we took h as the maximum height, h by 2 will be, no, u won't be 0 here because we don't know what is u. We don't know whether it was thrown at it. And since it takes some velocity in order to counter the gravitational acceleration, u is something that we don't know. So 10 squared is 100 is equal to u squared minus gh, because 2 in the numerator and the denominator gets cancelled. So let's keep u squared minus gh is equal to 100 as an equation 1. Next thing we need to do is we need to use the third equation again, but this time for the situation where the object reaches maximum height. So again, we have v squared is equal to u squared minus 2gs. Now here, at maximum height, the final velocity v will always be 0. So it is 0, 0 squared is still 0, is equal to u squared minus 2gh. So now we can find the value of u squared as 2gh. Using this value, so now we'll put u squared in equation 1. And our equation 1 was 100 is equal to u squared minus gh. And we know the value of u squared as 2gh using what we just did. So 2gh minus gh. So 100 is equal to g into h. Now let's find the value of h. H is 100 by g, and g is given as 10, so 100 by 10. So h is equal to 10 meters. The final maximum height is equal to 10 meters. That is option A. Now let's look at this question. A body is released from the top of the tower h meters high. It takes t seconds to reach the ground. Where is the body after t by 2 seconds of release? So, how do we solve this question? Let's write down the values. A body is released. That should give you the value of u as 0. And it takes t seconds to reach the ground, so the time is t. And since this is vertical motion, the value of acceleration is equal to g, so that is 10 meters per second square. And the total height is given as capital H. So now what do we do? Let's find out the value of capital H. So what we do is we use the second equation. So that is S is equal to UT plus half GT squared. So instead of HS, it will be H. So therefore, H will be equal to U is 0 into T plus half into G into T squared. So that is equal to half GT squared. Now you might be tempted to use 10 in here, but I urge you to keep your horses and write H is equal to half GT squared as equation number 1. So now we consider small h to be the height of the object after t by 2 seconds. So over here, we need to find out where is the body after 3.5 seconds of release. So basically, we need to find the value of small h. So let's draw the diagram. The total distance is h, and after t½ seconds, the body supposedly reaches a height small h. So we can understand that the distance of the fall, that is the distance traveled at t½ seconds, is capital H minus small h. And once again, we use the second equation of motion. So h minus h is equal to 0 times t by 2 plus half into g into t by 2 whole square. So capital H minus small h is equal to half g t squared by 4. That is the squaring. So 2 into 4 is 8. So that is 1 by 8 gt squared, h minus h. Now what we do, so we consider this as equation 2. So we divide equation 2 by 1. So therefore, we get capital H minus small h divided by capital H is equal to 1 by 8 gt squared divided by 1 by 2 gt squared. So t squared gets cancelled, g gets cancelled. So h minus h divided by h will be equal to 1 by 8 divided by 1 by 2. So that is equal to 1 by 8 times 2, which is equal to 2 by 8, which is equal to 1 by 4. So we can write capital H minus small h divided by capital H is equal to 1 by 4. What do we do now? We use cross multiplication. So 4 capital H minus 4 small h is equal to capital H. Let's take 4h to the right-hand side and capital H to the left. So we get 4/8 small h is equal to 4 into capital H minus capital H. So that is 3 capital H. So therefore, we can get small h as 3h by 4. And that is our final answer. So option A at 3h by 4 meters from the ground is the right answer. So the value of small h, the position of the body after t½ seconds of release, is 3h by 4. Let's move on to our final question of the day. A body starts from rest with an acceleration a1. After 2 seconds, another body B starts with rest with an acceleration a2. If they travel equal distances in the 5th second after the start of A, the ratio A1 is to A2 will be equal to. So the question gives us the condition that they travel equal distances in the 5th second after the start of A. So the distance traveled in 5th second for the object with acceleration a1 will be equal to the distance traveled in 3rd second for the object with acceleration a2, because the object a2 is released after 2 seconds. So the condition is that the distance traveled in 5th second will be equal to the distance traveled in 3rd second. How do we solve this question? How do you find the distance traveled in any number of seconds? So the distance traveled in n second, the formula is Sn is equal to u plus 2n minus 1 times a divided by 2. Okay? So now for acceleration is equal to a1, we have u is equal to 0. So, and then we have time is equal to 5 seconds. So the distance traveled in n second is u, here it is 0 plus 2n minus 1. So that is 2 into n here is 5. 2 into 5 minus 1 into the acceleration a1 divided by 2. So what we get is 10 minus 1 by 2 times a1. So the distance traveled in the fifth second is 9 by 2 a1. Similarly, for acceleration is equal to a2, the u is equal to 0, and the time, which is equal to n, is equal to 3 seconds. So s of 3 would be equal to 0 plus 2 into 3 minus 1 into a2 divided by 2. So that is 6 minus 1 by 2 a2, which is equal to 5 by 2 a2. So the distance traveled in fifth second is 9 by 2 a1. The distance traveled in third second is 5 by 2 a2. So now, since s5 is equal to s3, we can write 9 by 2 a1 is equal to 5 by 2 a2. So since 2 is common here, we can write 9a1 is equal to 5a2. So on rearranging, we'll get a1 by a2 will be equal to 5 divided by 9. And that is the ratio of the two acceleration. So a1 by a2 will be equal to 5:9. That is option C. And so that ends this episode of NEET preparation. There are a lot of questions in motion of a straight line regarding calculations of distance, speed, time, etc. So there are a lot of questions, and therefore we'll be back with more episodes on NEET preparation regarding the chapter motion in a straight line. If you haven't watched our first episodes of NEET physics on units and measurements, then please do watch, because those concepts can be important when you solve questions on motion in a straight line. So keep in touch and click the description and click the links in the description, which will lead you to the first chapter. And if you want to get more updates from our channel, Brain Blitz Audios, regarding the latest in educational content, such as LearnAwards, mind maps, NEET preparation, CBSE board exams, memory hacks, etc., then you can subscribe to our channel, and you can click that notifications button in the description down below so that you can receive updates about our latest content. So until the next episode, take care, stay safe, bye-bye for now.